Imagine this. You're working near a high voltage equipment. There is a flash, a burst of heat, and fire in an instant. In that split second, what you are wearing matters more than anything else. Not your helmet, not your gloves, but the fabric that you're wearing. Because the right fabric can mean a big difference between a life and death in these close call situations. And these fabrics are called flame retardant fabrics. And right now they are protecting millions of workers around the world in oil and gas, firefighting, electrical utilities, aviation, and manufacturing. In this video, we are going to know about everything about these flame retardant fabrics, what they are, how they work, how they are even made, and why they matter. So let's get in. Now, before we get into the details, let us understand what flame retardant fabrics are. Flame retardant fabrics are specific textile fabrics that are engineered to resist ignition, slow the spread of fire, and reduce the risk of serious injuries from burns. So why do we need these flame retardant fabrics? Well, the ordinary fabrics can easily catch fire. They fuel blaze. Some even melt and stick to skin, making injuries far more worse. Flame retardant fabrics do the exact opposite. They act as a barrier between you and the source. And one of their most important features, it's self-extinguishing behavior. Once the heat source is removed, the fabric stops burning on its own. It doesn't keep spreading. This single property can dramatically reduce the severity of a burn injury and give someone seconds they need to get to safety. You will find these fabrics in oil refineries, power plants, military uniforms, aircraft interiors, and even public spaces like theaters and auditoriums. They are not fireproof. Nothing truly is, but they give people time, and in emergencies, time is everything. So how do they work? So there are two ways to make a fabric flame retardant. The first is the inherent flame resistance. Here the production is built directly into the fiber's molecular structure. It can't be washed out, it can't wear off. It is part of the material itself. Aramid fibers, Modacrylic fibers, PBI, and FR viscose blends are all examples of inherently flame resistant materials. The second method is chemical treatment. Standard fabrics like cottons are finished with specialized flame retardant chemicals. These create a protective layer that resists ignition and slows flame speed. Both approaches work, but they differ in durability, longevity, and cost. That difference matters a lot when you are selecting the type of fabric based on the industry and the end use. Let's get into the history of flame retardant fabrics. Well, the idea of flame retardant fabrics is not something new. In fact, it is much older than what you may think. In ancient Greece, asbestos fibers were woven into clothes because of their natural resistance to heat. The first documented chemical treatment came much later, in 1735, when inventor Obadiah Wilde used alum and mineral salts to improve textile fire resistance. The real leap forward came in the 20th century. As industries expanded and workplace became more hazardous, the demand for proper protective clothing grew. In 1967, DuPont introduced Nomex, an aramid fiber that would change everything. Nomex became the standard for firefighters, military personnel, and industrial workers almost immediately. By the late 20th century, international standards like NFPA 2112 and ISO 11612 established clear performance requirements for fire-resistant fabrics. Those standards still guide the industry even today. How flame retardant fabric is made. Manufacturing these flame retardant fabrics is a multi-stage process, and every stage matters. It starts with fiber selection. The fiber determines everything that comes after: the level of production, the comfort, and durability. The common flame-resistant fibers include aramids, Modacrylics, PBI, fire-resistance viscose, treated cotton. Each has its own strength. Aramids offer outstanding heat resistance. Fire-resistance cotton is affordable and breathable. PBI is used in the most extreme environments. Next comes the weaving or the knitting part. Fibers are spun into yarn, then woven into fabric. Industrial garments typically use twill, ripstop, or even plain weave constructions, built for durability and long-term performance. Weave density also matters when it comes to fire-resistant fabrics. A tighter weave limits oxygen flow, slows the flame speed. Finally is the finishing. For non-inherent flame-resistant fabrics, this is where flame resistance is added. Manufacturers apply phosphorus-based treatments, ammonia curing systems, or polymer grafting technologies. After treatment, fabrics are cured, washed, tested, and often given additional finishes for oil repellency, anti-static protection, moisture management, or chemical resistance. The result is multi-hazard protective textile and not just a fire-resistant one. Now let's talk about some of the key properties of fire-resistant fabrics. What actually make these fabrics so effective? Here are a few key properties. The first, of course, is flame resistance. They resist ignition and self-extinguish when the heat is removed. Thermal stability. They hold their structure even under extreme temperatures. They don't melt, they don't rip. Char formation. When exposed to fire, many flame-resistant fabrics form a protective char layer on the surface. That char layer insulates the skin beneath it, slowly transferring heat. Non-melting behavior. This is one of the most important behaviors that makes the flame-resistant fabrics stand out. Unlike standard polyester or nylon, flame-resistant fabrics won't fuse to skin during a fire incident. This dramatically reduces the chances of skin burn. Durability. Quality flame-resistant fabrics maintain their protection through repeated washing and heavy use. Inherent flame-resistant fabrics are especially long-lasting, and modern flame-resistant fabrics are also comfortable to wear. Lightweight constructions, moisture-wicking technology, breathable blends mean workers don't have to sacrifice comfort for safety. Here are some widely used applications of flame-resistant fabrics in general. These fabrics show up across a wide range of industries, and we are just selecting a few just to get you a taste of what this flame-resistant fabric has its applications for. The first, of course, is oil and gas industry. Flash fires, sparks, and extreme heats are constant hazards. Flame-resistant coveralls and protective suits are standard issue here. Electrical utilities. Arc flashes can generate temperatures hotter than the surface of the sun. Arc-rated, fire-resistant clothing is essential for anyone working near high-voltage systems. Fire services. Firefighters depend on advanced flame-resistant fabrics in their turnout gear. Nomex and PBI are among the most widely used. Manufacturing, welding, metal fabrication, and other hot work environments all rely on flame-resistant fabrics. Aviation, aircraft interiors are lined with flame-resistant textiles to improve passenger safety. Public spaces, hotels, theaters, auditoriums, and cinemas regularly use flame-resistant curtains and upholstery. In fact, in many countries, this is required by law. Now let's talk about different types of flame-resistant fabrics. Not all flame-resistant fabrics are same. The first is the aramid fibers. Like Nomex and Kevlar blends are among the best known, outstanding heat resistance, durability, and non-melting behavior, widely used in firefighting, military, and aerospace. Modacrylic blends, soft, comfortable, self-extinguishing, popular in industrial uniforms. Fire resistance cotton, one of the most affordable options, common in oil and gas, construction, and general industry use. PBI fabrics, these are among the most advanced ones, used where thermal protection demands are the highest. Fire resistance viscose, often blended with other fabrics to improve comfort and breathability. Carbon-based fibers, engineered for specialized extreme heat applications in aerospace and advanced industry. Environmental impact. As sustainability becomes a priority for textile industry in general, flame-resistant fabrics are also facing a tighter scrutiny, and rightly so. Inherently, flame-resistant fabrics require energy-intensive production methods, but they last significantly longer, reducing the needs for replacements. Treated cotton raises several questions about chemical finishings, the environmental footprint, and overall the whole cotton value chain. Historically, some flame-retardant fabrics were also hazardous. The industry has been moving away from those and towards safer phosphorus-based, nitrogen-based, and halogen-free technologies. Many manufacturers are also adopting closed-loop water systems and more energy-efficient processes. That being said, there is still a lot of work to do, but the progress is happening. And the long lifespan of these materials does help to reduce the overall waste. Flame retardant fabrics are not just a product category, they are genuinely a life-saving technology. From the firefighter entering a burning building to the electrician working near the live circuits, to the refinery worker working in an oil rig during midnight, these fabrics are doing their job every single day. At Hula Global, we help brands and businesses source high performance fabrics and textiles that meet modern safety, quality, and compliance standards. If you found this video helpful, please press the like button, subscribe, and hit the bell icon so that you do not miss our next one. We cover fabric guides, sourcing insights, and textile innovations. So if that's your world, we would love to have you along. Thanks for watching. I'll see you in the next one.